So we're going to talk about red-headed woodpeckers, which is it has become an exceedingly uncommon bird today. There are some places in North America where they are more common than others. They used to be much more common here in Wisconsin, and I did my master's thesis work on this species and why it was declining, and we're going to go into that some more. But let's just tell you some basic information about them to start out with. Was a very common bird throughout eastern North America through the 1950s. Their population declined within the last 70 years, but that's not the first time this has happened. So has declined approximately 50% across North America and as much as 65% in some parts of Wisconsin. In fact, the decline in the 1990s, in some counties in eastern Wisconsin was as much as 90 to 95%. But there are some signs of local resurgence now. The decline in Wisconsin became noticeable after about 1940, and I'm going to go into the reasons at least as well as we understand them. Mm-hmm. The Breeding Bird Survey, which is a federal program done every year since 1965, indicate a significant population decline of 4.6% per year over the past 40 years. So my data ran up to 2019, but it's continued the same. This has amounted to a range-wide 50% population reduction since 1966. The Christmas bird count indicates a similar population decline in winter, with both a decrease in the number of individuals and the number of individuals observed per party hour. That's how Christmas bird count keeps their data. Recent changes may indicate some resurgence in some areas, but not all. Local population increases have been associated with increased beaver populations and the creation of flooded forests with dead snags for nesting. And they're closely tied to a range of tree diseases, and we'll go into that too, such as those affecting American elm and more recently, the ash. So red-headed woodpeckers are what we call sexually monomorphic. That means the adult males and females are identical in appearance. You have to be a bander to be able to tell one apart. If you have one in your hand, banders can look at the site on the vent where the reproductive organs are located, and then they can tell you whether it's a male or a female. And you can tell sometimes by behavior in the nesting season. But the rest of the year, if you see one flying, one is not larger than the other and their plumage is the same. So it's really almost impossible to tell them apart then. They are true cavity nesters, excavating cavities only in dead or dying trees. So what do I mean by that? Well, either the entire tree has to be composed of dead wood or at least one large dead limb. They will not excavate a cavity in a living tree, and they do not use nest boxes provided by humans. So where do they like to be? Well, really open deciduous woodlands, especially oaks. They really like oak savanna. Oak savanna once occupied 5.5 million acres in Wisconsin. Only about 500 acres of that pre-settlement quality savanna remain. There are some savanna parcels that are being managed and brought back into better condition, but as you can see, from 5.5 million down to several hundred is a huge decrease. So less than 1/100th of 1% of the original area. Habitat in summer, that's what an oak savanna looks like up in the upper left-hand corner there. Although redheads fundamentally a bird of open woodlands and savanna. It uses different woodland types in various areas of its geographic range in different seasons. Now you can see that photo in the lower left, that's cottonwood woodland along a river course in Nebraska. That's a place that you're likely to find redheads commonly in summer. And then in winter, they move to the southern US states generally, and they can be found in these huge flooded, uh, swampy woodlands. That's another place they prefer to be, but they're more likely to be there in the winter. So here are some primary reasons for the decline. Habitat loss and alteration. I mean, how many times have you heard that phrase that relates to almost all the wildlife species that you can think of? The second one, and a little bit harder to get at, is this competition between starlings and red-headed woodpeckers. Interestingly, in my thesis work, I was not able to show strong interference competition statistically, but I have lots of anecdotal information that point to that. And other people who have done work on starlings and redheads show a clear, strong competition between the two of them. Vehicle-caused mortality. Well, this is a really interesting situation. So back in the 1950s, one of Wisconsin's earlier ornithologists did a road mortality study over a 60-mile route that he and his wife used to take every weekend to visit his mother-in-law in Illinois. And he counted birds that had been killed on the highway for that entire distance over a period of 16 years. What I did in 1999, I had 95 cooperators in 62 of Wisconsin's 72 counties counting highway killed birds for me. And the population of redheads had declined so much by then that when this earlier study was done way back in the 50s, red-headed woodpecker was the second most commonly killed bird. There's a reason for this. They have a kind of a low flight speed. They only fly maybe 20 miles an hour. And when they're flying from one area of oak woodland across the road to another, they often fly quite low to the road, making them easily hit by cars and trucks. So second most common in the 50s to the second last out of about 110 species killed by cars in 1999. So it was a tremendous change. Then this last thing, loss of American elms to Dutch elm disease. Some of you may remember we had common American elms back in the 1950s and still somewhat into the 60s. But by that time, Dutch elm disease, which was another imported disease, had started killing elm trees. In many cases, when an individual tree started dying, the tree remained standing sometimes for 10 or 15 years, even after the entire tree was dead. But then it was either cut down by humans, or if it was in a forest, it occasionally blew down in a windstorm. So as the American elms began to be more frequent victims of this disease, for a period of about 10 or 15 years, red-headed woodpecker populations actually increased because there was a lot more standing dead material across the state. So hundreds of thousands of dead and dying trees. And that made good nesting substrate for redheads, and they used it. But then after those trees began to be lost, either again through windstorms or humans cutting them down, the red-headed woodpecker population took a nosedive. And there's a graph in my thesis that shows this. and it's actually a mirror image. So there's very clearly an association with that. So here's a graph of data from the 60s into the mid 2010s. That central line with the dot, that's the actual line. The two outer lines are confidence intervals. So this clearly shows a significant decline from the 1960s through about 2015 or 2016 on this particular graph. And it looks like a playground slide in the sense that it's a steep decline going from the right or from the left to the right. Here's a map of Pennsylvania to compare, right? So this is during the second Pennsylvania Breeding Bird Atlas, and you can see that huge areas of the state had no records of red-headed woodpeckers anymore by the time their second breeding bird atlas was done in the early 2000s. So this map is from my data. This is showing the negative change in red-headed woodpecker numbers on 55 breeding bird survey routes analyzed. So the size of the red circle equates to the percent change in the population mean. And you can see almost all of those circles are red, some of them fairly large, showing a over 76% population decline. On this particular map, there's only one green circle right there in Columbia County, which actually showed a positive number. So by that time, the decline was pretty severe. So what I did is I used air photos from those breeding bird survey routes along 8 routes in Wisconsin, using air photos from 2 different time periods in the 1970s and again in the 1990s. And that image on the right shows a composite of air photos from, well, that's now 65 years ago on one breeding bird survey route. Each air photo composite, I added the BBS route as a new line theme in ArcGIS, that's software for geographic information system, along with a buffer 500 meters on either side of the route. This 1,000 meter wide zone was the sampled area within which habitat patches were delineated and measured. So areas of woodland habitat within this sampled area were digitized as polygons. I'm going to show you a picture of that in a minute. Woodland patches of any size and configuration were measured, including those with trees within 3 to 4 crown diameters of one another. So picture a kind of an open woodland where there's a grassy understory underneath those oaks. And the oaks are not close together like in a true forest. This is really savanna or savanna-like habitat. So you can see all of these areas that were digitized and made into polygons. They're shown in that magenta color there, and it shows that more than 9% of woodland habitat area has been lost along that one breeding bird survey route that's named Princeton, which is kind of in Marquette County, between those 2 time periods. Where woodland habitat has increased since the 70s, in many cases, the trees are not large enough or old enough to become potential red-headed woodpecker nest sites. Woodland containing larger dead trees, which we often call snags, or live trees with at least some dead limbs, are necessary to provide habitat and usable nest sites for redheads. 3 of the 8 breeding bird survey routes analyzed showed habitat area increases ranging from just 10% to about 30%. The other 5 showed habitat area loss ranging from minus 2.5% to minus 38%. So here's you can see this route is running north and south broadly, and the habitat areas remaining are considerably less. So this is the route that had more than 38% of the woodland habitat lost. The red-headed woodpecker population in this particular area has declined more than 95%. So then I did statistical analyses of these. I did an analysis of what's called a landscape metric, a change in habitat area, and a similar change in the population of red-headed woodpeckers along those breeding bird survey routes for the 8 routes from both time periods. I used a technique called the Spearman rank correlation test, and the null hypothesis, that's HO, was that there was no correlation between change in the habitat area and red-headed woodpecker numbers. If you're familiar with those kind of statistics, you try to show that the null hypothesis is incorrect, or that the alternative hypothesis, HA, was that there was a correlation. So here's the data of habitat area and red-headed woodpecker count from the 1970s into the 1990s. You see that middle column there, they're all negative numbers, right? So that shows the loss of red-headed woodpecker. The second column from the left is a percent change in area. And then you see that important column third from the right, which is rank, right? That's of these 8 routes, how those rank. You use this test statistic, right? My hypothesis test was using a table value, the test statistic at alpha equals 0.05 was determined to be 0.63. The critical value determined was 0.8095. Therefore, I reject HO. Well, what does this mean? This test determines that there is clearly a correlation between change in woodland area and a percent change in numbers of the redhead. The loss of open oak woodland or savanna along those Wisconsin breeding bird survey routes was likely a factor. Remember, you've heard this said many times, correlation does not mean causation or does not equal causation, right? So we think of it as a potential cause or a likely cause, but does that mean that we've actually proven that it is the cause? No. So tree diseases are a big deal for this species and lots of other tree nesting birds, of course. Tree diseases such as Dutch elm disease caused the loss of all those American elms. That really had an effect on this species from the 1960s into the 1980s. You can see that lower left-hand picture. Maybe you remember American elms in your neighborhood that died and were taken down. So now we're experiencing something similar. We're losing many of our ash trees, really millions of them throughout the Midwest, right? You can see a similar kind of beetle activity under the bark in those smaller photos, both on the left and the right. So since all those dying elms produced good nesting substrate for redheads, I'm going to go out on a limb, that's my little pun, and predict that the same is going to be true for ash trees. And I've actually seen excavated cavities in ash trees within the last 10 years. Now, have I measured all of this? No. Someone could, though. right? So here's where emerald ash borer is really where their first detections. You can see the kind of a key down in the lower middle there. What year the first detections of emerald ash borer occurred. So some of those southeastern Wisconsin counties, it was fairly early from 2008 to 2012. Go a little further north in the central part of the state, 2013 through 16. And then as you go further north, 2017 to 2019, well, you can find since 2019 that practically the entire state has bloomed with emerald ash borer occurrence by now. So here's a very unusual map, one of the first what are called change maps for the second Wisconsin Breeding Bird Atlas. All those blocks that are in red show where redheads were found during the first atlas, which was 1995 to 2001. The green blocks are the second atlas, which took place between 2015 to 2020. The blue blocks are where they occurred in both locations exactly. So both Atlas 1 and Atlas 2. You can see a kind of an interesting movement to the northwest in the state. So the real core of the range for redheads is really the driftless area, so the southwestern third of Wisconsin, but we seem to be seeing a little bit of range expansion into the northwest part of the state. How long that will hold true, we don't know. The image on the right shows the map of where emerald ash borer is the worst, and I think that we're going to see at least some temporary improvement in red-headed woodpecker numbers because they're going to take advantage of these dead ash trees for nesting substrate. Management of red-headed woodpeckers and their habitat could slow the present population decline. I had a colleague who worked for the U.S. Fish and Wildlife Service. He worked at Necedah National Wildlife Refuge in west central Wisconsin, and he actually did management of their woodlands. He did it in stages. First, he held a timber sale where they came in and they harvested some oak. Then he saved all of the snags, all of the partially dead or completely dead trees in that whole landscape. And within a few years, red-headed woodpecker numbers really increased dramatically. So that kind of deliberate management for this species is really one of the keys to maintaining it and potentially bringing it back. That's my last slide, so I'll gladly take any of your questions.